Warm greetings to everyone present here. Today I am going to give a lecture on the design of thin cylindrical shell, which is of diameter small d and external diameter is capital D. And the spherical shell is subjected to an internal pressure of 5 Newton per square millimeter, and the thickness of the shell is 5 millimeter, and the allowable stress in the material of the spherical shell should not exceed 100 Newton per square millimeter. How to find the diameter of the spherical shell? All of you know that the thin spherical shell is most economical compared to the thin cylindrical shell, because there is no maximum shear stress or shear stress at anywhere in the section of the shell. That is the greatest advantage. Now we know that the hoop stress and the launch stress in the case of spherical shell is F1 is equal to F2, that is equal to the pressure inside the fluid pressure into the diameter of the shell divided by 4 times the thickness of the shell. So therefore F1 is equal to F2 is equal to PD by 4T. And you know that F1 and F2 are equal here, that is equal to 100 Newton per square millimeter. It is given in the problem itself, that is equal to the pressure is 5 into diameter is unknown D divided by 4 into 5, where 5 is the thickness of the spherical shell. If you are simplifying these values, we are getting the diameter, so which is of 400 mm. 400 mm is the inside diameter of the thin spherical shell. So 400 millimeter or 0.4 meter. Now if you are able to find the circumference stress and the launch stress in the spherical shell, that is F1 is equal to F2, that is equal to PD by 4T, that is equal to 5 into 400 divided by 4 into 5. So you are getting a value of 100 Newton per square millimeter. So the value of the circumference stress and hoop stress or the launch stress value is equal to 100 Newton per square millimeter. So this is the way you have to design the diameter of the spherical shell, or if the diameter is given, the pressure and the allowable stress in this given, you can find the thickness also. So both are called as the design of thin spherical shell. So that is the major advantage of this spherical shell of thin one. So you are not getting any shear stress at anywhere in the section of the thin spherical shells. So but in the case of thin cylindrical shell, you are getting the maximum shear stress and also the shear stress at a certain point of the thin cylindrical shell, that already we have seen in the previous videos. So the diameter of the thin spherical shell is equal to 400 mm. The outer diameter is 400 plus 2 into thickness, that is 400 plus 2 into thickness is 5 means, right? So 400 plus 10, that is equal to 410 millimeter is the outer diameter. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன். Now I am showing the problem which is worked out. You can see the diameter is 400 mm and the thickness is given. You can find the diameter, or the diameter is given, pressure is given, and the allowable stress is given. You can find the thickness also. So this is about the design of thin spherical shell. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.